Okay. ఇక్కడ okay. Today we are going to do Ziehl-Neelsen staining. Okay, one of the important staining that will be given in your practical examination. Gram staining and Ziehl-Neelsen staining. What are the steps, procedure of gram staining? Gram staining, what is the procedure? Take out your mask. There is no necessity to wear mask. Sit down. What is the procedure of gram staining? You have to remember it is a 4-step procedure. Okay. So first one is violet, you put violet. Second is iodine. Third is acid, alcohol or acetone. And fourth one is carbamazepine. Gram positive organism look violet in color. Gram negative organism look pink in color. Gram positive organism look pink in color. So example of gram positive cocci are, what are the example of gram positive cocci? Staphylococci. What is the morphology of Staphylococci? Gram positive cocci and clusters. Hold like this. They divide in all the planes. Daughter cells fail to separate out from other cells. They are arranged in clusters. Streptococci, they are arranged in single plane because daughter cells fail to separate out. It looks like serpent. Okay. The next one is pneumococci. It is lancet shaped or flame shaped, 2 cocci enclosed in a single capsule. It is called pneumococci because it is infects the lung, giving rise to pneumonia. Next one is meningococci. It is half moon shaped, plane surface facing each other. Next is gonococci, kidney shaped, concave end facing each other. The first 2 cocci are gram positive. First 3 cocci are gram positive. First 3 cocci are gram positive. And next is a gram negative. These are positive, gram positive, and these are negative. So bacilli are rod-shaped organisms. They measures about 3 micron in length and 0.3 micron breadth. So they are also classified on 3 criteria. One is gram staining, second is spore forming capacity, and third one is acid fastness. Gram positive bacilli is Corynebacterium diphtheriae. Hold like this. Corynebacterium diphtheriae. They divide like stem or shoot of the tree. Daughter cells fail to separate out from other cells. They are arranged in a L or V shape. It's also called as Chinese letter pattern. Next is Lactobacilli, because they are called Lactobacilli present in the milk. Erysipelathrix, it gives rise to skin exanthemata. It's also gram positive. Next is Listeria monocytogenes. It gives rise to meningitis. Then spore bearing organism, one forms spores in presence of oxygen. Anthrax, in the absence of oxygen, that is, anthrax is arranged in bamboo stick appearance. Gram positive. It is arranged in bamboo stick appearance. And next is Clostridium welchi. It has got terminal terminal spore. It is called drumstick appearance. It is a terminal spore. It is called as drumstick appearance. So Clostridium, they got 3 species: Clostridium welchi, Clostridium tetani, Clostridium botulinum. Now there are a group of organisms which are neither cocci nor bacilli. They are with the mnemonic, you should remember, BBHY. BBHY stands for Borrelia, Bordetella, Brucella, Haemophilus, Yersinia. Bordetella pertussis causes whooping cough, brucellosis causes undulant fever, Haemophilus influenza causes neonatal meningitis, Yersinia pestis causes plague. Now moving on to the next group of organisms, which are called as they are comma shaped organism. Example, they are gram negative. They are comma shaped and they are motile with the single polar flagellum. They are motile with the single polar flagellum. They are motile with the single polar flagellum. Next group of organism is spiral shaped. One is rigid, that is spirillum manus, which gives rise to rat bed fever. Another is flexible. Again, there are 3 genera in this. One is Borrelia. Borrelia recurrentis gives rise to relapsing fever. Leptospira ectohemorrhagia gives rise to bacterial jaundice. Then Treponema pallidum gives rise to syphilis. Treponema pallidum gives rise to syphilis. So these are the group of organisms which are spiral in shape. Then there is higher branching bacteria, that is actinomycetes, and it can infect the cervical, abdominal and pelvic area. Actinomyces and nocardia, they can give rise to mycetoma of the foot. Then there is an organism which is cell wall-less. It is called as Mycoplasma pneumoniae. So you should remember all the morphology of bacteria that will be asked in your examination. And actually today's practical is Zeal-Nielsen staining. Zeal-Nielsen staining is classified. It's also gram staining is also differential staining. Differential staining. Gram staining is also differential staining. Gram positive look violet in color. Everybody repeat: gram positive look violet in color. Gram negative look pink in color. So Staphylococci, Streptococci, Pneumococci are gram positive. Gonococci, Meningococci are gram negative. So example of gram positive bacilli are Lactobacilli, Corynebacterium, Erysipelathrix, Lactobacilli, Clostridium, Anthrax. Gram negative bacilli are Salmonella, Shigella, Proteus, Vibrio cholerae, Spirochetes. These are all gram negative. So please remember, this will be one of your practical exercise, final year practical exercise, and we'll ask an internal assessment also. It's very important to know about this. Today's topic is Zeal-Nielsen staining. Zeal-Nielsen stain. It is done for staining Mycobacterium tuberculosis. Mycobacterium tuberculosis. It is called Mycobacterium tuberculosis because earlier it thought to be a fungi, that is myco. It fulfilled called Koch's postulates. It's called bacterium, and it causes tuberculosis. Tuberculosis is a lesion, chronic granulomatous lesion. It's called tubercle. It has got central area of caseation necrosis surrounded by monocyte macrophages. There is a special giant cell called Langhans giant cell. So all of us are susceptible for tuberculosis. 1/3 of world population is carrying this tuberculosis bacilli in their lungs. The primary tuberculosis is called gonfocus. The secondary focus is reactivation occurs. Now what we have started is tuberculosis elimination program. So man get infected by the inhalation. Man get infected by the inhalation. There will be small patchy infection in the upper lobe, and hilar gland lymph nodes get enlarged, and this is called Ghon's focus. This is called Ghon's focus or primary complex. So in the reactivation occurs in adulthood if the man suffer from viral fever or becomes immunocompromised, smoker, alcoholics, diabetics, reactivation occurs. So it gives rise to tubercle in the lung. So the central area is caseation necrosis, is like a butter surrounded by macrophages, and there is a giant cell called Langhans giant cell. Surrounding area is a Langhans giant cell. So it spreads to the pleura, it gives rise to pleural effusion. If it is breaks down into RBCs, it gives rise to miliary tuberculosis, and it can goes to brain. It can give rise to tuberculosis covering of the brain, meningitis. It can go to the kidneys. It can give rise to renal tuberculosis, and bones. It can give rise to osteomyelitis of the bone. So in fact tuberculosis infect each and every organs of the body except hair and nail. Except hair. 70 to 80% of tuberculosis infects the lung. So the sputum that we take is sputum. Early morning sputum is best, and it is collected in a wide mouth bottle, perfectly labeled with patient's name, IPOP number. It should be all written, and now barcodes have come. We give barcodes to each specimens. Once it comes to the lab, we fix the smear to the slide. Heat acts as a fixative, and usually put it as Ziehl-Neelsen staining. Okay, now it is a mnemonic. You remember CAM. For the gram staining, you remember mnemonic VIAC. Whereas for tuberculosis, you remember it as CAM. So you cover the smear with concentrated carbamazepine. You cover the smear with concentrated carbamazepine. Heat it intermittently. For 5 to 7 minutes. This makes dye to go inside the cytoplasm, because gram stain, it is not easily stained because it has got a thick wall made up of mycolic acid. It's a thick wall which is made up of mycolic acid. So you have to intermittent heat it from beneath for 5 to 7 minutes, taking care not to char, burn or break the slide. Taking care not to burn, char or break the slide. Taking care not to. Then decolorize with 10 to 20% either sulfuric acid, hydrochloric acid, drop by drop until the faint color remains. Drop by drop until the faint color remains. Counter stain with methylene blue. Counter stain with methylene blue for 30 seconds to 1 minute. Wash, blot dry, wash, blot dry, and see under oil immersion microscope. See under oil immersion microscope. See under oil immersion microscope. Once see under the microscope, you have to adjust under the oil immersion. 100x objective, put the oil on the smear and touch the 100x objective to the oil and bring it up until you see fainting. With finer adjustment, you adjust until you see the bacilli. Then you draw the diagram. The background should be blue in color. The background should be blue in color. Okay. These bacilli are long, slender, slightly curved. They look pink in color. Pink colored bacilli, and other things all look blue. Other colors all look blue. For example, there is Staphylococci, there is pus cells, they all look blue. Now, once you stain, your report should be long, slender, slightly curved, beaded, branching, acid fast, bacilli are seen, morphologically resembling Mycobacterium tuberculosis. Mycobacterium tuberculosis. So once you finish, the examiner will come and ask why they are acid fast. You should say because they have thick mycolic acid. That's why they are acid fast. They have a thick mycolic acid. Cell wall is made up of mycolic acid. That's why they are acid fast. Cell wall is made up. Now next question they will ask is, what is the other acid fast organism? Other acid fast organism is Mycobacterium leprae. So what are the differences between MTB and M. leprae? So it is long, slender, slightly curved, branched, beaded appearance, whereas it looks short, stumpy. It's called as cigar bundle appearance. Short, stumpy. It's called as cigar bundle appearance. Mycobacterium tuberculosis is 20% acid fast, whereas Mycobacterium leprae is 5% acid fast. So usually the clinical specimen is the sputum. It is skin scraping, especially from the ear lobules or the thickened skin. Skin scraping. From the skin scraping. Usually from the skin scraping. Now next is it can be grown on Lowenstein junction medium, LJ medium. It cannot be grown. It is grown in foot pad of mouse. Foot pad of mouse or 9-banded animal called armadillo. 9-banded animal called armadillo. 9-banded animal called armadillo. So once again I'll repeat the procedure. So take the smear and facing upwards. Most of the students stain on the reverse side of the smear, end up breaking the slide. Please don't do that mistake in the examination. Cover the smear with concentrated carbamazepine. Repeat everybody. Cover the smear with concentrated carbamazepine. Heat it intermittently for 5 to 7 minutes, taking care not to break, char the slide. Then afterwards wash, decolorize with 20% hydrochloric or sulfuric acid, drop by drop until faint color remains. Counter stain with methylene blue for 30 seconds to 1 minute. Wash, blot dry, see under oil immersion microscope. So these are the two stains that are given in examination. Gram staining procedure, you repeat with me. Cover the smear with gentian violet. Any violet can be used. Most commonly we use gentian violet, methyl violet, crystal violet. Cover the smear with gentian violet 1 to 2 minutes. 1 to 2 minutes. Wash, blot dry. Add grams iodine for 30 minutes to 1 second. Wash, blot dry. Decolorize with acetone or alcohol until a faint color remains. Counter stain with, here dilute carbamazepine. There it is concentrated carbamazepine. It is a dilute carbamazepine. Wash, blot dry. See under oil immersion microscope. Gram positive organism look violet in color, whereas gram negative organism look pink in color. Then they will be asked questions why some organism take violet and why some organism look pink in color. You have to say gram positive cell wall is thick. Gram positive cell wall is thick. They don't give away the primary stain. And gram negative cell wall is made up of lipid, and alcohol is used as a lipid solvent. It gives away the alcohol diiodine complex. The second thing is acidic pH. Gram positive is acidic. They have more affinity towards basic dye. So third one is chemical theory. There are two chemicals, that is magnesium ribonuclease and teichoic acid. Magnesium ribonuclease and teichoic acid. So the postulates can be this is cell wall theory, this is pH theory, this is chemical theory. So cell wall is thicker in gram positive and gram negative is complex. It is made up of more lipid. Alcohol is a lipid solvent, gives away the diiodine complex. Chemicals, teichoic acid and magnesium ribonuclease holds back the primary stain. And third one is electrical pH. pH, that is acidic pH, that gives rise to the more affinity towards basic dye. So example of gram positive staph, everybody repeat with the example of gram positive cocci are. Gram positive cocci are Staphylococci, Streptococci, Staphylococci, Streptococci, Pneumococci, whereas meningococci and gonococci are gram negative. Example of gram positive bacilli are Corynebacterium diphtheriae, Lactobacilli, Erysipelathrix rosopathiae, Anthrax and Clostridium. And even tuberculosis and leprobacilli are gram positive, but they are not stained because of thick mycolic acid in the cell wall. Gram negative bacilli, rest are all gram negative. Salmonella, Shigella, Proteus, Pseudomonas, E. coli, Klebsiella, Spirochetes and Coccobacilli are all gram negative. Bordetella, Brucella, Haemophilus, Yersinia. These are all gram negative. Now move to the practical hall where we are going to do the Ziehl-Neelsen staining. So everybody will do the Ziehl-Neelsen staining. Okay, thank you.